Enjoy with Mathematics Series 5. Chapter 3: Factors and Multiples. Looking back, numbers that are multiplied to get a product are known as factors. 6 multiplied by 4 equals 24. 6 and 4 are factors of 24. Factors of a number also divide that number without any remainder. 27 divided by 3 equals 9. 9 and 3 are both factors of 27. Remember, 1 is a factor of every number. It is also the smallest factor of a number. Every number is a factor of itself. It is also the greatest factor of that number. The factor of a number is less than or equal to the number. Every number, other than 1, has at least 2 factors. That is, 1 and the number itself. When a number is multiplied by 1, 2, 3, 4, etc., the products are all multiples of the numbers. 4 multiplied by 1, 8. 4 multiplied by 2, 12. 4 multiplied by 3, 16. 4 multiplied by 4 are all multiples of 4. Remember, a number is a multiple of itself. Every number is a multiple of 1. Every multiple of a number is greater than or equal to the number itself. There is no end to the multiples for a particular number. 1. Write the factors of a. 18, b. 28, c. 56, d. 60, e. 90. 2. Write the common factors of a. 13 and 65, b. 9 and 15, c. 14 and 12, d. 27 and 54, e. 18 and 21. 3. Write the first 5 multiples of a. 3, b. 8, c. 10, d. 14, e. 17. 4. Write the first 2 common multiples of a. 2 and 7, b. 4 and 8, c. 5 and 6, d. 3 and 5, e. 4 and 3. Rules of divisibility. The rules of divisibility will help to find which numbers divide others without leaving a remainder. Divisibility by 2, 5, 10. A number is divisible by, if the last digit, number, divisible by 2, 0, 2, 4, 6, 8, 2, 5, 10, 5, 0, 5, 22, right, wrong, wrong, 10, 0, 30, right, right, right. Divisibility by 3 and 9. A number is divisible by 3, 9, if the sum of the digits is divisible by 3, 9. Number, 72, 84, sum of digits, 7 plus 2 equals 9, 8 plus 4 equals 12, divisible by 3, 9, right, 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 wrong. Prime and composite numbers. Let us find the factors of the numbers 1 to 10 by finding how many rectangles each we can arrange them into. Factor of 1 is 1. Factors of 2 is 1, 2. Factors of 3 is 1, 3. Factors 1, 1, 2, 1, 2, 3, 1, 3, 4, 1, 2, 4, 5, 1, 5, 6, 1, 2, 4, 6, 7, 1, 7, 8, 1, 2, 4, 8, 9, 1, 3, 9, 10, 1, 2, 5, 10. Factors of 4 is 1, 2, 4. Factors of 5 is 1, 5. Factors of 6 is 1, 2, 3, 6. Factors of 7 is 1, 7. Factors of 8 is 1, 2, 4, 8. Factors of 9 is 1, 3, 9. Factors of 10 is 1, 2, 5, 10. What do you observe on seeing the figures given on previous page and also the above figures? we find that there are some numbers for which we can make only 2 rectangles. Or, in other words, some of the numbers have only 2 factors themselves and the number 1. Prime numbers. A prime number is any number more than 1 that has only 2 factors, the number itself and the number 1. For example, the numbers 2, 3, 5 and 7 have only 2 factors each, the number itself and the number 1. Such numbers are called prime numbers. When 2 primes have a difference of 2, they are called twin primes. For example, 3 and 5 or 5 and 7 are twin primes. Composite numbers. A composite number is any number greater than 1 that has more than 2 different factors. For example, 6 has 4 factors. They are 1, 2, 3 and 6. 6 is called a composite number. Remember, 2 is the only prime number. 2 and 5 are the only prime numbers that end with 2 and 5. There are no other prime numbers that end with these digits. The number 1 has only 1 factor. It is neither prime nor composite. Primes between 1 and 100. A Greek mathematician, named Eratosthenes, long ago found a simple method of locating prime numbers from 1 to 100. This is called the sieve of Eratosthenes. All the numbers that are not crossed out are prime numbers. Remember, cross 1 as it is neither prime nor composite. Leave 2 as it is a prime number but cross out all the products that appear in the tables of 2. Leave 3 as it is prime, but cross out all its multiples. Leave 5, but cross all its multiples. Leave 7, but cross all its multiples. Prime factorization. All composite numbers can be broken up into their factors. When the factors are all prime, it is called the prime factorization of the number. Prime factorization of 20 equals 2 multiplied by 2 multiplied by 5. Prime factorization method. A. Find the prime factors of 64. Step 1. Start with smallest prime factor of 64. Step 2. Next find the smallest prime factor of 32. Step 3. Continue to find the smallest prime factors at every step. Stop when the last row has only prime numbers. Check. 2 multiply by 2. Multiply by 2. Multiply by 2. Multiply by 2. Multiply by 2 equals 64. This is another way of writing prime factorization. B. Find the prime factors of 48 using the prime factorization method. 48 equals 2 multiplied by 24 equals 2 multiplied by 2. Multiply by 12 equals 2 multiplied by 2 multiplied by 2 multiplied by 6 equals 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. Answer. The prime factorization of 48 equals 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. Division method of prime factorization. Let us find the prime factors of 36 using the division method. Step 1. Start with the lowest prime number that is a factor of 36. Quotient. Step 2. Take lowest prime number that is a factor of 18. Quotient. Step 3. Take the lowest prime number that is a factor of 9. Stop when the quotient is a prime number. Step 4. Multiply all the divisors and the last quotient. Answer. The prime factorization of 36 equals 2 multiplied by 2 multiplied by 3 multiplied by 3. Highest common factor, HCF. You have already learned about common factors in the previous class. Now let us look at the common factors of 12 and 18. Factors of 12 is 1, 2, 3, 4, 6, 12. Factors of 18 is 1, 2, 3, 6, 9, 18. Factors of 12. Factors of 18. Common factors of 12 and 18. The common factors of 12 and 18 are 1, 2, 3 and 6. The highest common factor, HCF, of 12 and 18 is 6. Remember, the HCF of two numbers is the greatest number that divides both numbers without leaving any remainder. The HCF is also called the GCD, that is the greatest common divisor. To find the HCF using the prime factorization method, let us find the HCF of 24 and 32 by prime factorization method. Step 1. Do the prime factorization of the numbers. Step 2. Find the common factors. Common factors are 2, 2, 2. Step 3. Multiply the common factors. 2 multiplied by 2 multiplied by 2 equals 8. Answer. HCF of 24 and 32 is 8. To find the HCF using the common division method of prime factorization. The common division method of prime factorization can be used to find the HCF. A. Find the HCF of 45 and 72 using the common division method of prime factorization. Step 1. Divide the numbers by the lowest common prime number. Write the quotients below the numbers. Step 2. Then divide the quotients by the lowest common prime number. Step 3. Stop when there are no common prime numbers to divide by. The HCF is the product of all the common factors. Answer. HCF equals 3 multiplied by 3 equals 9. B. Find the HCF of 25, 17, 21. There are no common prime factors for these given numbers. The only common factor is 1. Therefore, the HCF is 1. Answer. HCF equals 1. Remember, numbers that have 1 as their HCF are called co-primes. The numbers themselves may or may not be prime numbers. Every two consecutive numbers are co-prime. The HCF is the greatest factor that divides the given numbers without leaving a remainder. The HCF of given numbers cannot be bigger than any one of them. Lowest common multiple. Observe the number line that shows the multiples of 2 on top and the multiples of 3 below. The places where the two multiples meet are the common multiples. 6, 12, 18. The lowest of these is the first place where both multiples meet, that is, at 6. 6 is the lowest common multiple, LCM, of 2 and 3. Remember, the LCM of two or more numbers is the smallest number that can be divided by those numbers without leaving a remainder. To find the LCM by prime factorization. A. Let us find the LCM of 16 and 20 by prime factorization. Step 1. Find the prime factors of 16. Step 2. Find the prime factors of 20. Step 3. Multiply the common factors and the factors that are not common. Answer. LCM equals 2 times 2 times 2 times 2 times 5 equals 80. B. Find the LCM of 50, 30, 18. Prime factors of 50 equals. Prime factors of 30 equals. Prime factors of 18 equals. Answer. LCM equals 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5 equals 450. To find the LCM by the common division method. A. Find the LCM of 12, 15 and 18 using the common division method. Step 1. Divide by the smallest prime number that can divide at least two of the numbers. Bring the ones that cannot be divided down as it is. Step 2. Keep dividing by the smallest possible prime number till the last row has only prime numbers or numbers that have only one as a common factor, co-primes. Step 3. Multiply all the factors and all the numbers in the last row to get the LCM. 2 times 2 times 3 times 1 times 5 times 3 equals 180. Answer. LCM equals 180. B. Find the LCM of 144, 180 and 384. LCM equals 2 times 2 times 2 times 2 times 3 times 3 times 1 times 5 times 8 equals 5760. Answer. LCM equals 5760.